So we now moved on to relations and functions. So we defined that the relation shows the relationship between input and output. So input, that's the first, and the output is the second. So the input is what you put in, and the output is something that will come out. So mathematically, a relation is any set of ordered pairs. So anything that's composed of ordered pairs. So ordered pairs is just you have the x and the y element. So the x and the y uh, a pair of them, sets. So I said sets, not just one, but more. But you can also have one. So that's a relation. So in this case, we have here 1, 2, 3, 4, 5 sets of ordered pairs, and the inputs are 1, 3, 3, 5, and 8. The rest are the outputs. So for the domain, it's actually R refers to the input, so collection of the first values in the ordered pair. So in this case, we have 1, 3, 3, 5, 8. But when we will be writing them in set form, we will not be repeating 3. So as you can see earlier, we have 2 threes, but we are only going to write it once. So these are the set of ordered pairs. When you are asked to write down the domain, you have to write it, enclose it in a brace, and separate it with commas. So the output values are called the range. So it's a collection of the second values. So in our example, we have 2, 4, -6, 7, and 6. So in this case, the second values are not repeated. So we list down everything. So you have 2, 4, -6, 7, and 6. For the sake of order, we can write them, arrange them properly in order. So we start with -6, 2, 4, then we have 6, and then 7. So this is the set of output values. So what's the difference now between relations and functions? Functions are actually relation, but what makes it unique is that a function has one output for each given input. So let's define further. Let's unlock. Uh, it's a set of ordered pairs still, just like relations. It's a set of ordered pairs having the property that no two distinct ordered pairs have the same first entry. So that means we cannot repeat our domain or our input. So in this case, we have this is set A, and the second one is our set B. So every element in A is paired with exactly one element in B. So they have a unique pair, each of them. So this is a relation, but this is a special kind of relation because our first set is paired with exactly the same pair here in the second set. So this is how do you call it? This is a function, a special kind of relation. Here, for our first set, so every element in A is paired with an element in B. But here, there are only two elements in B, so that means the elements in B are repeated. But we are only going to focus with the elements in A. A elements in A are not repeated. So this relation is called a function. So it's still a function. So our focus is only the first set. Next, this is the opposite of the previous example. So here, there are only two elements in A, but we repeat the elements in A and paired it with the elements of B. So here, we used the elements in A several times. So this is not a function. It's just a mere relation. So let's try to determine the domain and the range. Then we decide whether whether the relation is a function. So let's start with domain. So our domain here, we list down. We start with the smallest, -5. Then we have 2, 4, and 5. Well, for our range, the smallest is -3. Then we have 3. 3 is repeated twice. And we have 7. Take note that for us to determine if the relation is a function is to look only at the first values or the domain. So not one domain is being repeated. Therefore, this relation is a function. Next, so for the second example, 1 is repeated twice, so we will have to write it once, and the second element is 3. For the range, we have -2, don't forget the brace, 2, and then 7, sorry, that's supposed to be 7. That's 7, and then close. So as you can see, 1 is being repeated, so it appeared twice. Therefore, this is not a function. This is a mere relation. Next, we have t is equal to, start with -5, -4, -3, and -2. Not one, appeared twice. And we have the range is -1, 0, 1, and 2. So, not 1 again in the domain that is being repeated. Therefore, this relation is a function. So here, our domain, our 8 repeats 3 times. So we only write 8, and our range, 6, 7, 8. So is this a function or a relation? This is a mere relation because 8 is being repeated.